The universe is full of mysteries, and it often takes years of staring at something to figure out what it could be. But what if you don't have years? What if you just have one split second? That's what's happened with so-called fast radio bursts. For a decade, astronomers have been struggling to understand these weird events which appear as a flash of radio waves in a random part of the sky. But this week, according to a paper published in the journal Nature, we might have finally figured out what causes at least one of them. Fast radio bursts, or FRBs, are called fast for a reason. Each event lasts for just a couple of milliseconds, and then it never appears again. Usually. In 2015, astronomers noticed that one they'd previously observed repeats. It's called FRB 121102, and the signal comes from a dwarf galaxy about 3 billion light-years from us. Since then, it's been observed a handful of times, and in this new paper, researchers published a new guess about what might be causing it. After collecting 18 new observations, the authors focused on the length of the bursts, along with two aspects of the radio waves, their dispersion and their polarization. A wave's dispersion describes how much one frequency gets separated from another. Even if an object emits a bunch of frequencies at once, they might reach Earth at different times because of how they pass through space. Kind of like how a prism can separate white light into a rainbow. So dispersion can indicate things about the conditions around where the wave was emitted. On the other hand, polarization, which involves the direction waves travel, provides insight into the emitter itself. In this case, all the observations had roughly the same polarization, and that told the scientists that whatever created the bursts has a constant orientation relative to Earth. Beside that, some of these bursts were almost astonishingly short. One lasted just 30 microseconds. That implies that whatever created it was about 10 kilometers across, which just so happens to be about the size of a neutron star, the dense cores left over from smaller supernovas. The observations also showed that the source of the burst was surrounded by a cloud of electrons and bathed in a violent magnetic field. Astronomers usually associate those conditions with the space around a black hole. So one possible scenario is that this FRB comes from a poor, tortured neutron star being jostled by a nearby black hole. Or it might be a neutron star surrounded by the remnants of a supernova, or even something completely different. We'll need more research to figure it out. Still, even if we do figure out the source for sure, there are a lot of other questions to answer. Like, we don't really know how a neutron star would cause these bursts, even if we can confirm that's where they're coming from. So part of the mystery might be solved, but we've still got a long way to go. But that isn't the only star-themed discovery we made recently. Using observations made with the creatively named Very Large Telescope in Chile, astronomers reported that the universe might have way more massive stars than expected. They published their findings last week in the journal Science. Since the 1950s, it's been believed that large stars are incredibly rare, but that's been tough to check because besides being really large, these stars don't tend to last very long, so it's hard to find a bunch of them in one area. Astronomers are especially interested in these objects because they end their lives in powerful supernovas, which could produce the universe's heavy elements like gold, nickel, and uranium. And stars like them also shaped the early universe with powerful radiation, so they have a lot to teach us. To try and study multiple stars at once, these scientists looked at the nearby Large Magellanic Cloud, one of our satellite galaxies, only about 160,000 light-years away. Within the cloud lies the Tarantula Nebula, one of the most active starburst regions in our local universe. These regions are places where a lot of stars are made in a relatively short period of time, which makes them especially useful for research. In this latest study, when the scientists observed the nebula, they found dramatically more high-mass stars than predicted. For example, they found 30% more stars more than 30 times the mass of our Sun, and for stars more than 60 times as massive, it was an extra 73%. They even found a star weighing more than 200 solar masses, although it probably got heavier over time. The authors argue that taken together, their data implies that stars can be born with masses up to 300 times more than the Sun, which is twice the previously accepted limit. Also, since these giant stars burn through their fuel and die much more quickly than stars like our Sun, these results imply that we should see a lot more deaths, too. Specifically, when stars like this die, they can turn into supernovas and create black holes. So based on these findings, the team estimates that one type of supernova should occur around 70% more often than expected, and that there could be nearly triple as many black holes in the universe. All these big conclusions, though, only hold true if the Tarantula Nebula isn't like a special case of star formation. To know that, astronomers will have to make more observations of other starburst regions. Because, you know, you didn't think all the work was done, did you? If you learn anything from SciShow Space, it's that there's always more work to be done. If you want to stay up to date with the Tarantula Nebula and all kinds of space news, you can go to youtube.com/SciShowSpace and subscribe. SciShow Space is the first spin-off show of SciShow, and it's been steadily growing over the last few years. And if you like it and want to help it grow, please tell your friends about it. We're so close to 1 million subscribers. Getting excited.